For the class, we are looking at Module 2, Chapters 3 and 4, Review, Practice Test. Chapter 3, Functions, and Chapter 4, Linear Functions. Before we delve into a few questions, a quick recall about a few things. The difference quotient as the formula f of x plus h minus f of x over h, where h can't be 0. In essence, it's the rise over run, okay, the good old slope. Dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. Okay, now look at this concept of a domain and range. Let's just look at a couple of definitions. First, relation, a set of ordered pairs. Domain, the set of all input values, x values, independent variable. The set of all output values, y values, or dependent variable is known as the range. So as we look at the graphs, the domain would be all possible values of x along the x-axis. You can see it here, or you can see it here. The range, all possible values of the y-axis. You can see it from this graph, or you can see it from this graph, going up and down all the way from negative to positive infinity. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range, and therefore it can pass the vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. The last but not least, a function is considered to be a one-to-one function if each element in the range corresponds to exactly one element in the domain, and it has to pass the horizontal line test. Now, what is a horizontal line test? If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. Okay. Now we want to find the domain for the following equations or functions, starting with part A. You're dealing with a rational function. A rational function is defined everywhere except where the denominator is 0. So you set the denominator 2x minus 1 equal to 0 and exclude that. So that gives us x equals 1/2. So we have to exclude that. All real numbers are fine except 1/2. So we could write it as such, but in interval notation, that means the domain goes from negative infinity to 1/2 union 1/2 to infinity. Parentheses mean that the end points are not included, okay? In this case, 1/2 is not included. Also, we always use parentheses for negative as well as positive infinity. F of x is square root of 5x plus 4. Anytime the index is even, index. And I hope you realize, since we don't write this, the index is 2. There is a limitation, and the limitation is 5x plus 4. What's underneath must be greater than or equal to 0. And that means x is larger than or equal to negative 4/5. And this is the inequality format, and this is the interval format. Finally, f of x equals x squared. The domain is all real numbers. Why is that? It's a polynomial. What is the degree? 2. That means it's a quadratic function. Second question is similar to that. Cube root of x. Domain is all real numbers. Why is that? Index is an odd number. Anytime the index is odd, the domain is all real numbers. This is also a rational expression. So this rational equation, denominator set it equal to 0 and exclude that. X squared minus 1 is 0, which is x equal to plus minus 1. So your domain is all real numbers except those numbers. So you could write it in this fashion, and that's okay, but we want to know the interval notation. Negative infinity to negative 1. Look at the parentheses, that means it's not included. Union, negative 1 to 1, union, positive 1 to infinity. This is positive 1, everybody. So I hope everybody is fine with that. Okay. So with that being the case, let's look at the last one. F of x is 2/3 x plus 7. Domain, all real numbers. Why is that? It's a linear function. Or you could say it's just a line or a polynomial of degree 1. Okay. We want to determine if the graph represents a function. We just went over the definition so we can handle this. We also want to come up with the domain and range. So if you look at the first one, is this a function? Yes. Why? It passes a vertical line test. Is this a one-to-one function? Yes. Why is that? It passes a horizontal line test. Okay. In other words, can you come up with any vertical line that crosses the graph more than once? No. So it's a function. Can you come up with a horizontal line that crosses the graph more than once? No. So it is both a function as well as a one-to-one function. So what about the domain? Along the x-axis, we're going to cover from 2 to 8. 2 has a hole, so 2 is not included. Okay, so 2 to 8, okay, but 2 is not included. And along the y-axis, we're going to go from 6 to 8. Okay, so along the x-axis, we don't cover the 2, but we cover everything to here. And using a different color. This is covered. This is not. That's your range. So we write it as follows. Yes, it is a function, also a one-to-one function. Here's the domain, here's the range. Let's look at the second case. Is this a function? Yes. Can you come up with a vertical line that crosses a graph more than once? No. So this is a function. But is it a one-to-one function? Can you come up with a horizontal line that crosses the graph more than once? Yes, of course. Let me just look at this one. Okay. Or let's just, here's one example that creates it. Domain. Okay, so along the x-axis, it covers this point. Okay, so this covers this point all the way to here and not the last. So that's your domain. Use a different color for the range. The range covers from here all the way to here. This whole thing is covered. So let's answer the question. Yes, it is a function. No, it is not a one-to-one function. Domain goes from -3 to +2, and 2 is not included. The range from -5 to 4, everything is included. The last one, it fails the vertical line test as well as the horizontal line test. I hope you see that. I can just draw something like that. So no, it's not a function. No, it's not a one-to-one function. So what is the domain? Let's use a different color here. Along the x-axis, I hope you see that covers here to here, and along the y-axis, it covers from here to here. And so domain -4 to 0, range 0 to 4, and the endpoints are also included. The next one, we have a function f of x equals to x plus 1, and we want to find and simplify the expression f of x plus h minus f of x over h. This is the good old slope, rise over run, also known as y sub 2 minus y sub 1 over x sub 2 over x sub 1. That's the same thing. So rates of change, the difference quotient, this is the difference quotient. Normally we use this one, delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. That is also known as a difference quotient. Let me just fix this. This is f of x sub 2 minus f of x sub 1, okay? F of x sub 2, f of x sub 1. So it's important to see that there is a typo here, okay? There's a typo. Maybe I rewrite it here as f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And so it's called the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ if you happen to have a curve and you connect 2 points. That's your secant line. There are different ways of writing them. M, or delta y over delta x, is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, if we use x sub 1 and x sub 2. F of b minus f of a over b minus a, if we use a and b. If we call this one b instead of x sub 2 and this one a. Or if we call this one b instead of a plus h. When we use a and b, we get this one. If we use a and a plus h, we get this one. If we just use x and a, we use this one. So they all refer to the same thing. So let's evaluate this. How do we do that? F of x equals 2x plus 1. We want f of x plus h. We are going to replace the x with x plus h. That would be f of x plus h, and then minus, we just write f of x here. All you have to do, simplify the numerator accordingly. We are going to distribute the 2. We get 2x plus 2h. Okay, and we write the rest. So what happens now? We are going to simplify The numerator is left with 2h only divided by h. The final answer is 2. Now f of x is 2x squared plus 1, g of x is 3x minus 5, and we want to find the following. So a quick reminder, f plus g of x is f of x plus minus g of x. That's the operation, okay? The algebra function. F g of x is f of x times g of x. F over g of x is f of x over g of x. So the sum function, the difference function, the product function, the quotient function. We also have a composite function. F of g means f of g of x, g of f means g of f of x. And it's a little illustration of what we have seen and what it means as far as their domain is concerned, domain and range, okay? Now, if you're interested in finding f of g of 2, first we have to find g of 2. So what is g of 2? Replace the x with 2. 3 times 2 minus 5 results in 6 minus 5 or 1. Therefore, f of g of 2 is equal to f of 1. So now replace the x here with 1 and you're done. Pretty straightforward. F of g of x, basically f of g is f of g of x. So replace the x in this function with the g function. So replace the x with 3x minus 5. So what we have to do, we have to raise this to the power of 2. By now, everybody remembers that a plus b squared is a squared plus 2ab plus b squared. So you're going to square this. So 2 times you're going to square this, which is 9x squared. Then 2 times the first times the last one, 2 times 3, 6x times minus 5. Okay, becomes negative 30x. And then minus 5 when you square it, you get positive 25. And don't forget, we have a 1 at the end. So 2 times 9x squared is 18x squared. 2 times minus 30x is minus 60x. 2 times 25 is 50. We add the 1, 51. We want g of f of x. So replace this x with f of x. So 3 times 2x squared plus 1 minus 5. This gives us 6x squared. This gives us 3. We add negative 5 and it gives us negative 2. So we can write 6x squared plus 3 minus 5, and then the final answer. We want to get a couple more here. G of x. Okay, that means g of g of x. That means g of g of x. And by g of x, we mean replace the x with the function itself. Now, when we apply, this becomes 9x. This becomes minus 15. We also have a negative 5 minus 2. F of negative 2, that means f of negative 2. So we find f of negative 2 first by putting negative 2 into this function. So 2 times negative 2 quantity squared plus 1. This is 4. Two times 4, 8 plus 1 is 9. Therefore, we are looking at f of 9. F of 9. So you are going to replace the 9 here. This is 81. So 2 times 81 plus 1 it gives you 163. We want to find out whether the function is an odd or even function. So what was the definition? Recall. Even function f of minus x equals f of x, which refers to symmetry with respect WRT with respect to the y-axis. F of minus x equals minus f of x. This is an odd function and it's symmetric with respect to the origin. So let's find f of minus x. Replacing the x with negative x. When you square that, you get the same thing. So it becomes 2x squared plus 1. Because it is equal to the original function f of x, it is considered to be an even function. G of x, let's replace the x with negative 1. Replacing the x with negative 1 results in minus 3x minus 5. So you're going to ask yourself, is this equal to g of x? No, it's not an even function. Is this equal to the opposite of that? No, so it's not an odd function either. Therefore, g of x is neither odd nor even. Neither odd nor even. We want to find the average rate of change of each function in the given interval. Again, reminding you of the same thing, rise over run. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So just plug in, okay? So we are going to go from negative 1 to 1. Please understand this is not a pair. We are going from x equals negative 1 to x equals positive 1. That's the meaning of it. Therefore, with this being the case, f of 1, look at this one. So f of 1 minus f of negative 1 over x sub 2, which is 1, minus x sub 1, which is negative 1. So that's the meaning of it. Therefore, f of 1, replace it with 1, you get 3, okay, minus 3 times negative 1, 3 times negative 1, denominator 1 minus negative 1. So I hope you realize that this is 3 plus 3 is equal to 6. This is 1 plus 1 equals 2. 6 halves, which is equal to 2. 6 halves, which is equal to 2. 6 halves, which is equal to 3. My apologies. And we're going to look at the next one in the same manner, where x sub 2 is a and x sub 1 is 4. We are going to look at this. So 2x minus 9, we are going to replace the x with x sub 2, which is a, minus the second time we're going to replace the x with x sub 1, which is 4. 2 times 4 minus 9. And the denominator is x sub 2 minus x sub 1, or a minus 4. All you have to do, simplify. So this is 2a minus 9, okay? And this is what? 8 minus 9, negative 1, which makes it plus 1. This one is negative 1, everybody. So the numerator is 2a minus 9 minus minus, that means plus 1. So 2a minus 8. You can factor the 2 out and drop the common factor of a minus 4. It results in 2 as your final answer. We're going to do the same thing here. So that means we are going to use this formula. We're going to put 2 plus h first. So 3 times 2 plus h plus 4. Minus, then we're going to put 2, 3 times 2 plus 4. And the denominator is this, 2 plus h minus this, minus 2. So we are looking at f of 2 plus h minus f of 2 over 2 plus h minus 2. Now, the order of animation is not proper, so let's just For now, ignore that. Let's see what happens. The intermediate steps I want to go over. 3 times 2 plus h plus 4 minus 3 times 2 plus 4 over h. As it appears, the numerator simplifies to 3h, and division by h gives us 3. But let's quickly write this at top of that. We are distributing number 3. We have 6 plus 3h plus 4. And I hope you realize this is 10, therefore minus 10. I can 6 plus 4 minus 10, they add up to 0. They add up to 0. Therefore, we have 3h over h equals 3 as the final answer. The following function was graphed by applying transformation to elementary functions. This functions class, there are some elementary functions, essential functions. Let me grab my pointer here. Toolkit, essential functions, elementary functions, functions that we should be familiar with. So quickly, let's discuss those. A constant function f of x equals b, okay. Y or f of x equals x. Y or f of x equals x squared. A basic parabola opening up. Y or f of x equals x cubed. Y or f of x is square root of x. Y or f of x equals cube root of x. There are more, okay. We will look at logarithmic functions, exponential functions. Also, absolute value function, okay. What is an absolute value function? I hope you remember it's just a V shape, and so is this. Therefore, we are dealing with an absolute value function. Absolute value function, y equals absolute value of x, the vertex is at 0, 0. Now, let's look at the new vertex. The new vertex has a location which is 3, negative 2. That means this has been shifted 3 units to the right and 2 units down. So we can start with that. And we're going to write it in this fashion because the number in front could be something else, okay? This is shifting to the right by 3 units, so minus 3, and shifting down. Because we are not too sure what happens in the front, we go with A, and all you have to do, pick up a pair and figure out A. Easy pairs, you can see the green ones, easy pairs, like 1, 0, 0, 1. You don't have to use both, of course. 1 is good enough simply because A is missing, okay? Pick up one of the pairs and plug in. For example, if we pick up the first pair, 1, 0, which is the x-intercept, that means replace the x with 1, replace the y with 0. 1 minus 3 is negative 2. The absolute value makes it positive 2. Therefore, A becomes 1. A becomes 1. Your final function is f of x equals the same thing here without the A. Absolute value of x minus 3 minus 2. So there were basically 2 transformations, 3 units to the right, 2 down. So the synopsis of the transformations, it is explained in the PowerPoint, yet let's just quickly recap this. If a function y equals f of x, we are assuming c is positive. We shift it to the right by c, we write f of x minus c, to the left f of x plus c, up by c units f of x plus c, down by c units f of x minus c. Again, we are assuming c is positive. Same thing, c is larger than 1. That is the assumption. So this is the basic function, okay, that we start with, y equals f of x. y equals c times f of x, okay? It has a stretch in a vertical direction by a factor of c. 1 over c, we are going to divide it by that. Minus f of x, it flips over with respect to the x-axis. Then if the negative is in front of the f of x, in essence is in front of the y coordinate, flips it over with respect to the x-axis. If we put the negative in front of the x inside, it flips, so x becomes minus x. Therefore, it flips over with respect to the y-axis. This is the synopsis of something that we have seen as part of transformation. Now we have two more examples and we want to see how to deal with them. Again, we are using these essential functions, the elementary functions, and we want to write the equation of a function that is given. When we look at the graph, we notice what we are dealing with here, which is the original function y, or f of x, is square root of x, starting with the intercept at 0, 0. And we locate the intercept has been moved and it has been shifted to the point -3, -1. Okay, so it has been shifted to the left and down. So -3 shifting to the left, that means add 3, and -1, just add this -1. And you must check, because we may have an a in front. The way you check it, you pick the easiest number you can locate. So I hope you see that -2, 0. Always go for easy numbers. So -2, 0, if you plug in -2, with 3 you get +1, square root of that is 1, and -1 adds up to 0. You don't need anything, although you can put the a and then plug in, make sure then a is found accordingly. When you look at this graph, you notice it's a parabola that opens down. I hope you remember the general formula. First of all, a parabola y equals x squared, and a general formula, the vertex format is a times x minus h quantity squared plus k. This is the vertex format. This is the general format. And in this case, the vertex is located at h comma k. We notice that the vertex of 0, 0 has gone to this point now that has coordinates -1 and 2. So we are going to replace this with -1, makes it x plus 1, and then replace this with 2. So that's the function. Now, a, generally speaking, you know it has flipped over, so it is negative. By the way, may not necessarily be just -1, but it is negative because it has flipped over. So again, you pick an easy pair, okay? I hope you see that y-intercept is an easy pair. You pick it up, 0, 1, and now you plug in, you replace the x with 0, y with 1. This is 1 square root of 1, a plus 2 is 1, a becomes -1, and you have your function there. Transformation. We continue with transformation as follows. We want to find the equation of a function that is finally graphed, starting with y equals x squared. So we are going to start with this, and we're going to shift to the right by how many units? 3 units. As we shift it to the right, we say x minus whatever the number of units, 3, so x minus 3 squared. Now we are dealing with this function. We are going to reflect it about the x-axis, okay, x-axis. So we put a negative in front of it. We're going to move it down by 2 units. We're going to add -2 because we are going down. This is the final equation. This is the final equation. We are given the graph. We want to estimate the intervals where the function is increasing, decreasing, local max, mean, so on and so forth. So this portion is increasing. This is decreasing, this is increasing. So increasing. So this takes place from here to here roughly, and from here, okay, along the x-axis to here. So this, if I want to change the color, so from roughly here to here, this is increasing, increasing. The green portion is decreasing. So we have increasing. First definition of increasing on an open interval. The short version of what you see here, a function is increasing in an interval I if for any choice of x sub 1 and x sub 2, x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. Is the definition for decreasing. A function is decreasing on an open interval I if for any choice of x sub 1 and x sub 2 in I with x sub 1 less than x sub 2, we have f of x sub 1 larger than f of x sub 2. What does it mean? Short version, x goes up, y goes up. This is increasing. As you go from left to right, x gets larger. If the y gets larger, also we say the function is increasing. On the other hand, in the case of a decreasing, when x goes up, the y value goes down. And in the case of a constant, of course, the values for f of x stay constant. You're looking at a horizontal line in essence. So here's the increasing portion, increasing from -8 to -3 union 3 to 7. Decreasing from here to here, -3 to 3. As far as the endpoint, in some text, they put this endpoint class, okay? And in some text, they put this endpoint, and in some text, they don't. Because you don't know what happens afterwards, it's really a good practice not to. But you want to stick with what my open math does to get a full credit. And decreasing from -3 to 3. Determine any local max or minimum value. This is a local max, this is local max, this is local min. So local max, you can guesstimate roughly that the local max has a y coordinate equals 50. I want to make sure everybody understands how we do the writing. Local max is equal to 50, and it takes place at x equals -3. You can say at x equals -3, or you can give a pair at -3, 50. What about local max? So that was local max. What about local mean? Takes place here, okay, and seems to be about -50, okay. So it takes place at +3. So it is equal to -50, and it takes place at 3, -50, or you can say at x equals 3. Now, that's local. That means in some open interval. I'll give you the definition, in a moment, the synopsis of the whole thing. Determine any absolute max or minimum value. Absolute or global refers to the entire domain, okay? So what is the absolute max? The endpoints can be absolute, they cannot be local, by the way. So the absolute, this happened to be the largest value. It seems to be 150. So the absolute max is what, 150, and it occurs roughly at 7. Okay. The absolute mean is here, appears to be maybe in between 200 and 250, so negative 225. And occurs at about negative 8. So this is a rough estimate, equals negative 225 at x equals negative 8. It is up to you. If you read it slightly different, it's not that big of a deal. Let's look at the definitions quickly before we move on to the next question. Okay. Absolute or global extreme values are either maximum or minimum points on a curve. The general word is extrema. Extrema refer to both max as well as min. Okay. And it is the plural for extreme. Extrema is the plural for extremum. So extrema means both. Okay. Extreme value theorem. Okay, so let's just continue with that thought, then I discuss that. Absolute mean occurs at the point C if f of c is less than or equal to f of x for all x values in the domain, in the entire domain. This is a local mean, this is a local max, this is a local mean, but this one is not only a local mean, it's also an absolute mean because no other point has a smaller y coordinate. Absolute max is the other way around. Local max, local mean, local max. This one is also an absolute max because no other point has a larger y coordinate. Relative or local refers to the same concept in some open interval. A local minimum is the minimum value within some open interval. This is a local mean, this is a local max. Local mean, local max. So I hope everybody is clear as to what we mean by absolute or global versus local or relative extreme. We also have extreme value theorem. If f is a continuous function whose domain is closed interval of a to b, then f has an absolute max as well as an absolute minimum on the interval of a to b if we happen to have a closed interval. That's what happens. Even function, we had defined it as f of minus x equals f of x, and odd function f of minus x is minus f of x. I hope everybody remembers that. We also define the increasing, decreasing, and constant function. So I thought the synopsis of that is interesting to see. Let's move on. For the following functions, find f inverse of x. A, f of x is 2x minus 7. B, f of x is x over x plus 2. So let's find the inverse. Number one, we are going to call this y because it makes life easier. Number two, we are going to interchange x and y. At this step, we do have the inverse. However, we don't stop there. We continue by solving for y. So solve for y. Your next step is elementary algebra. Solve for y. Move the negative 7, make it positive, divide by 2. Call this f inverse. So f inverse of x is x plus 7 over 2. Of course, you can prove this is right or wrong by looking at their composite function. I'll leave it for you to show this is a correct answer. You have to verify that by checking f of f inverse. We do exactly the same thing here. Number one, we call it y because it makes life easier. And number two, we are going to interchange x and y. So this becomes x, this becomes y, and now we do the cross product. So this is what I mean by cross product. So 1 times y is y, x times y, and x times 2. We are going to move it such that we can solve for y, okay? So we can, for example, move this one. On the right side, we factor out the y. And if we divide by 1 minus x, we get the y. Now we give it the name F inverse. What I want you to notice is this. F inverse is 2x over 1 minus x. If we had moved this in this step differently, okay? So if we had moved this one to the left and 2x to the right, then we would get minus 2x over x minus 1. Notice if you multiply the top by negative, you get negative 2x. If you multiply the bottom by negative, you get minus 1 plus x. So you're multiplying by negative 1 over negative 1. Both are correct. And again, I highly recommend you show what we are going to show here. To verify these two functions give us inverse functions. That means look at their FOF inverse. We must show FOF inverse equals x. By the way, one of them, FOF inverse or F inverse OF, makes no difference. And if we do that, we are going to replace the x with x cubed. This positive one will cancel out this negative one. We get to x cubed underneath, which is equal to x, and that's a proof. We want to find the inverse of this function as far as the graph is concerned. There are a couple of things you can do. Number one, you can draw the line y equals x carefully and reflect the graph of this function with respect to this line y equals x. To do this in a proper format, all you have to do, draw this line and then pick up a few easy points, okay? So let's do that. It appears that this point, okay, so f of minus 2 seems to be negative 4. Because this is the case, then f inverse of negative 4 must be negative 2. So if we have this point, corresponding to that, we have that. That was an easy point on the graph of the red function. Another one, f of 0 is 4, this point. Therefore, f inverse of 4 must be 0. So you see that you're locating this point and this point, this point and this point, and of course you have your y equals x. You can also pick up more points. These are just a couple of easy points that I'm referring to. You can pick up at least 2 more points just to be on the safe side, and the graph looks something like that, symmetric with respect to the line y equals x. I highly recommend you definitely pick up 2-3 more points and graph the corresponding function accordingly. I hope you see those points. I hope you see those points. Very simple, okay? We want to sketch the graph of a piecewise defined function that is defined as follows. What do we do? Well, we can pick up a few points. For example, -1. So if I want -1 because of the equality, I've got to put it in here. And between -1 and 1, we are using this. So if I want 0, I'm going to also use this one. Okay. If I want 1, I can't use this one. 1, when x is 1, is equal to 2. If I want larger than 1, for example, I want 2, so it's x larger than 1, I must go with that. 3, I must go with that. So take a look at what happens. We get those values because we are evaluating with a proper piece. You can plot those pairs and have a rough sketch. But before we do that, I want to show you something, and that is, what if we were to graph this one and this one without paying any attention to the restriction? First, I want you to see that. So graph the line y equals minus x plus 1 and graph the parabola y equals x squared on the same set of axes. And notice, this is the graph if we didn't pay any attention here. okay? But we are going to pay attention here. So for this line is restricted from -1 to 1. So at -1, okay, we have a dot, and at 1 we have a hole. Then x squared, this is x squared, and we can only start from 1 and have a hole there, okay? We also have at x equals 1, we have 2. So let's graph and see what happens. I want to make sure everybody understands what's going on. So here's the line. The restriction goes from -1 to 1. At -1, we have that, so it's solid. At +1, we don't, we have a hole. Then look at x squared, starts from 1 and goes up. There is a hole and goes up. And what about this one? This gives us the pair 1, 2, 1, 2. This is how you graph this. Domain, from -1 to infinity, everything is included, okay. Range from 0 to infinity, because the bottom of the graph is here and it goes all the way to infinity. But because of this hole, 0 is not included, class. 0 is not included, and we get a parentheses to represent that. All right, I changed to a headphone to be on the safe side. We are finding the average rate of change for this function from 2 to 4, which simply put means f of b minus f of a over b minus a. So we want f of 4 minus f of 2 over 4 minus 2. Let's do that first. The average rate of change. Now plug in 4, plug in 2. Elementary. 4 squared is 16, minus 3 times 4 is 12. You do the math, just simplify the numerator. Is 3. I'm assuming we are okay with simplification of that. That shouldn't be a problem. Six halves. Find the average rate of change of this function as we go from 4 to 4 plus h. In essence, this one or this one, if you will, where a is 4. So we write it in this fashion, and we are going to replace the x with 4 plus h first here, and then we're going to replace it with 4. So let's plug in 4 plus h. 4 plus h squared minus 3 times 4 plus h minus, now f of 4, 4 squared minus 3 times 4. Let's simplify the numerator. 4 plus h squared is 16 plus 8h plus h squared minus 12 minus 3h. This is 16, this is 12. We are going to simplify the numerator now. 16, 16, negative 12, positive 12. We have h squared left, 8h with negative 3h, they add up to positive 5h. Factor out the h, drop the common factor of h, you have the final answer. We want to find the value of x if a linear function goes through the following points. X comma 2 minus 4, 6, and the slope is 3. To refresh your memory, class, lines, this is the standard form, ax plus by equals c, slope intercept form, y equals mx plus b, point slope form, y minus y1 equals m times x minus x sub 1. Vertical lines in general, x equals a, slope is undefined. We have x-intercept at a0. Horizontal lines, HL horizontal lines, y equals b, slope is 0, y-intercept at 0b. Two lines are parallel, they have equal slopes, different y-intercepts. Two lines are perpendicular, that means they make a 90-degree angle at the point of intersection, then their slopes are negative reciprocal. You can multiply them and you get -1, or you can say one is -1 over the other one, So -1 over m sub 2, and m sub 2 is -1 over m sub 1. With that being the case, let's write this equation of a slope, rise over run. Therefore, we are going to write 6 minus 2 over minus 4 minus x equals m, which is 3, right? We do the cross product again as follows. Three times -4 minus x and 1 times 6 minus 2, which is 4. We distribute -12 minus 3x. We move the -2, becomes +2, with 4 becomes 16. Divide by -3. So -16/3 is the final answer. Consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. We are really looking at the slope-intercept form. Y equals mx plus b, and we're going to write p equals mt plus b, because we are changing the y to the p population, and we are changing the x, the independent variable, to the t time. A quick recap of what's happening. P of t is the population as a function of time. M is the constant rate of growth, which is 2,500 per year. T is the time since we began everything. B is the initial population of 75,000. Therefore, the linear function becomes 2,500. P of t is 2,500 t plus 75,000. Very straightforward. Monthly cost of a cellular plan depends on a number of minutes used and a flat fee. If we use 410 minutes, the cost is $71.50. 720 minutes, the cost is $118. We want to find the cost function. So to do that, it is important to come up with the equation of a linear function as follows. We are representing it with minutes and cost, okay? So minutes, you can use any variable that they set, in this case x, or if t, it's absolutely up to you if it's not given, but x is given, so x and c. C is a function of x. Therefore, 410 minutes, 71.50, 720 minutes, 118. We are going to use the slope. Remember, the slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We are going to say c sub 2 minus c sub 1 over x sub 2 minus x sub 1. So 118 minus 71.50 over 720 minus 410. That's the answer. Now we have to simplify. It becomes 46.5 over 310, 3 over 20, or 0.15. You can use either one as your slope. Ultimately, dealing with the money, decimal may be better, but let's start with one of them anyways, 3 over 20. Using the point slope, y minus y1 is m times x minus x sub 1. We're going to say c minus C sub 1, C minus, and we are going to use one of them. Let's say this one, C minus 1 over 18, M 0.15 or 3 over 20, X minus X sub 1 or 7 20. Distribute, simplify. I'm assuming everybody can do that. This is 3 over 20 times X. Then this one you divide by 20 and you multiply by 3 and you move the negative 118. You end up with the cost being 3 over 20 times X plus 10. That is part A, 3 over 20 or 0.50. What would be the cost if we use 687 minutes per month? You replace the X with 687. You multiply by 3, you divide by 20, and you add 10. Because it's money, we carry 2 decimals. It ends up being $113.05. Now, interpretation of the slope and the c-intercept is as follows. The c-intercept represents the fixed cost. What is that? That's flat fee. They are charging $10 no matter what. Meaning, even if we don't use the cell phone, they're going to charge us $10. What about the slope? 3 over 20 or 0.15. The slope represents the change in cost per minute of call for the amount of $0.15 per minute or 15 cents per minute. That's the meaning of this slope.